Hi, we're going to have a look at geometric sequences, a little bit of an intro into what they are and how to find the nth term and things like that. So far you've definitely come across a linear sequence, and that might look something like this, say 4, 7, 10, 13, 16. And if we look at the differences between each term, we can see that there is a difference of 3, and that's constant between each term. So there's a constant first difference, and that tells us that this is a linear sequence. Now this is a type of arithmetic sequence where we are adding a constant amount to get between terms. Another type of sequence that you may have seen would be a quadratic sequence, where when we look at the first set of differences, we see another pattern, and then we can drill down into the differences between each of those, and eventually we get to a constant second difference. So if we find a constant second difference, we know the sequence is a quadratic one. In other words, we know that its nth term will be something to do with n squared. If you found that there was a constant third difference, that would mean that the sequence would have an n cubed as part of its nth term, and that would be called a cubic sequence, and so on. Okay, so for constant fourth difference, that would be a quartic sequence, and so on. Geometric sequences aren't like those. We can't find out what we are adding to get between terms because we will just keep getting this pattern. Okay, so once we've found the differences, first set of differences, if we look at the second set of differences, they will be the same, and so on. So that will take us nowhere. What's different about geometric sequence is that it can be explained by timesing, by multiplying to get between different terms. Okay, so it's multiplying instead of adding. And you might think, well, I've come across a geometric sequence actually where I've divided, but actually you can explain that with a multiplication as well. Okay, so you could multiply by a fraction, and that would be the same as dividing. So how do we find the nth term of a geometric sequence? Well, we need to introduce you to a few bits of terminology first. So we call the first term A. So in my geometric sequence here, this I could call A. And we call the number we multiply each time the common ratio. So the common ratio in this question is 2. Okay, so if my first term is A, I could call my second term A times R, or AR. If I multiply that by R, again, the R would become R squared. So this third term is AR squared. Fourth term is AR cubed, and so on. Fifth term is AR to the power of 4. And if you look at these numbers, the numbers in the power versus the n number, position number in the sequence, it's always one less. Okay, and that even applies to these ones over here that appear to not have a power. A power of 1 would just be R, so we could put a power of 1 there if we wanted. And also a power of 0, remember anything to the power of 0 is just 1, so you could put R to the power of 0 there and it wouldn't make any difference, and the pattern would hold true. So in general, the nth term of a geometric sequence is the first term times the common ratio to the power of n minus 1. Okay, we see this a bit more at A-level maths. Not really expected to know this per se at GCSE maths, but having knowledge of it can become pretty useful. So watch out for this style of question. First term of a geometric progression is 5. Oh, by the way, this is another way to say geometric sequence progression. The third term is 80. What is the fifth term? Okay, or they may present it to you with shorthand notation like this. So what I would do is just write them in their positions. You could just guess what the other ones are. Okay, so what have I multiplied 5 by to get this number, and then multiplied by the same thing to get this? And after trying a few numbers, you probably guessed that it's 4. So that would give us 20 times 4 is 18. You could figure it out like that. Or you could use algebra. We know that we could call each of the terms these things. And if we did the third term divided by the first term, that would be doing AR squared divided by A. The A's would then cancel to just give us R squared. 80 divided by 5 is 16. So if R squared is 16, R must be 4, and we've worked out the constant ratio. and then we can figure out the other numbers. Okay, so on with the pack page now.